So this short lesson is going to look at subtracting mixed numbers. And similar to adding mixed numbers, the first thing we want to do is look at the fractions, and we want to subtract and work with the fractions first. So we'll do that, and then step 2 will be working with the whole numbers. But let's get the fractions first. 5/7 minus 3/7 is 2/7, and then 5 minus 3 is 2, and that's it. Fractions first, and then the whole numbers. Okay? But notice that this numerator was bigger than this numerator here, so it made the subtraction of the fractions pretty easy. Okay? Problem is, we might sometimes run into something like this. Now what happens if we run into something like 5 3/7 minus 3 5/7? Then we would get a situation where it would be 3 minus 5. So just a second, let me fill in this right here. Again, after subtracting the fractions, then we subtract the whole numbers. Now returning to this, we're going to do 3 minus 5. Well, if I put 3 pens on a table and ask you to grab 5 of them, that's not possible. Right? So we can't really do 3 minus 5 in that sense. Right? So we're going to have to change things around a little bit. And this is how we do that. First, let me give you a little reminder about fractions and when they equal 1. Well, when a fraction equals 1, what do you notice about its numerator and its denominator? Let me just give you a couple of examples. Right, when it equals 1, the numerator is the same as the denominator. 6 divided by 6 is 1. 5 divided by 5 is 1. 14 divided by 14 is 1. 20 divided by 20 is 1. So as long as the numerator is the same as the denominator, it's going to be equal to 1. Right? So we're going to need to remember that fact in order to change things around for this problem. So what I'm going to do is I'm going to take 1 away. So I'm going to lift this 5 up, and this is how you can kind of picture this. I'm going to lift this 5 up, crumple it, throw it away, okay? And now I'm left with 4. But unless I put back what was equivalent to 1, then I've completely changed the problem. So what is equal to 1 when we're working in sevenths? 7 out of 7 is what's equal to 1. So I went from 5 to 4, but I kept the problem the same by putting back 7/7 over here. Okay? So now up top what I have is 3/7 plus 7/7. So now what I have is 10/7 right here. And then over here, I have my 4 now. Okay? And now down here, I still have my 3 5/7. But now what you notice is I can now go ahead and subtract because 10 is bigger than 5. So 10 minus 5 is 5. And then now 4 minus 3 is 1. So my answer is 1 5/7. Alright, so bear in mind, if we had uncommon denominators, the first thing we'd have to do is get common denominators and then proceed from there. So this concludes this video. You saw the two different kinds of subtraction problems you're going to get. One where this numerator is larger than this numerator, and the other way around is the second option. So let me do one more if you need it. If not, this concludes this video. Okay, let's look at (11 2/9) minus 7 4/9. Now, if the 4 were up here and the 2 were down here, then we'd just do 4 minus 2 and get 2. But unfortunately, in this case, we have the 2 up here and the 4 down here, so we can't take 4 objects if I only put 2 of them on the table. Right? So we have to change this by thinking about picking up this 11, throwing it away, making it 10, and then we have to add back what 1 equals when we're working in ninths. And that is 9/9. 9/9 is what makes 1. Of course, 5/9 is less than 1. 11/9 is bigger than 1. The only thing that makes 1 is 9/9. So we're taking 1 here, but putting it back here. So now our problem becomes 10, and now we have 11/9 minus 7 4/9. So go to the fractions first. 11 minus 4 is 7. And 10 minus 7 is 3. So our answer is 3 7/9. 3 7/9. Now, this now officially concludes this lesson.